Well, good morning, everyone. Welcome to BAC, Bridge Automotive Company. Thanks for tuning in to this virtual tour of our factory. Before I get too far into things, I'd like to introduce myself. Those of you who don't know me, my name is Neil Briggs, so I'm the co-founder of the business with my brother Ian, along with all the team here, responsible for the car that we all know and love. And today we're going to take you on a journey through pretty much the entire business space that we've got here in Liverpool. Another lovely sunny day here in South Liverpool. But before I get too much into that, I just wanted to ask everyone how they're doing, really. It's tricky times that we find ourselves in currently. So I hope everyone's well, I hope your families are well, I hope you're managing to continue with your businesses and stay sane in amongst all of this lockdown. It's been a real challenging time for us as business leaders, and I think the automotive sector in general has been hit pretty massively. As an example, all of our neighbours here in South Liverpool, JLR, Ben, Vauxhall, they've all had major issues with power supply. Fortunately, because the vast majority of the parts that we source are from the local area and actually from the UK, we've managed to stay open. We've obviously been acting responsibly with regards to with COVID-19 and putting all the usual processes in place. We're running at about half the capacity at the moment in terms of our output, and of course, my responsibility, real main responsibility, is everyone's safety, to make sure also that the business comes out of it as healthy as it possibly can. So where we're standing at the moment is we're actually in our showroom space. So if you've ever visited the building, this is right at the front of the building. It's blisteringly hot in here today. We've got all this lovely glass so you can see the cars from outside. What that means is that it's also stiflingly hot in here today, so we won't stay in here too long. Of course, the first thing that we see, obviously, is this incredible car, which the team here designed, engineer, and produce. The original intention is to have the car here so that when you arrive, it's the first thing that you see. You're instantly switched on to what we're all about and our values. Some other things that you'll see in and around the showroom space, got some lovely iconic images. We've got a lot of awards which we have over the last 8 years of production. We've won many awards, both related to the product.
I'm not going anywhere. I'm not going to Richards or anything today because it's supposed to. I'm not going to go. I'm not doing. I don't know.
No, because I'm not.
A very good. It's not just a very good award-winning car, but it's also an award-winning business as well. And of course, that's very rewarding for the people who are based here. I guess the first question is why are we in Liverpool? Why are we based here? What's our main reasons for that? And that's quite an easy answer. Liverpool's been synonymous with car production for the last 58 years. JLR, literally just across the road, produce almost 5,000 cars a week. So it wasn't a difficult decision to base our business here. Liverpool is also a fantastic place to do business. For those of you who've never been to Liverpool, never visited the city, it's an incredible place to visit. It's the second most visited city outside the city of London. So if you ever fancy coming up to see us, come and see us, spend the weekend up at Liverpool, and who knows, come out and test drive of the car. A little bit of housekeeping. I've got my phone here and my glasses because age has got the better of me. And from time to time, you'll see me looking down at my phone. I'm not texting friends or family. I'm just making sure that I'm covering a lot of the points that I want to. So I didn't want people to be offended at that. So we've covered basically why we're in Liverpool. What I haven't mentioned is, and it's a lesser known fact actually, is the connections that we have to the city. Mayor Anderson opened this building back in incredibly nearly 6.5 years ago now, so on the 17th of December 2013. That was part of our business expansion, and we have a strategic investment partnership with Liverpool City Council. Obviously, it's all around job creation and skills, and essentially Liverpool see us as the cherry on the icing on the cake, if you will, for the rich automotive heritage that, as I said, Liverpool's had for the last almost 60 years. And we're very, very proud to be associated with a city that is very synonymous with culture, music and heritage. But what a lot of people don't know is that as a region, Liverpool is 10% above the national average for manufacturing. So there's a lot of successful manufacturing businesses that are based here in Liverpool. We're obviously tapping into some of that resource with the supply chain. So as an example, 50% of the parts that we'll see on this car are sourced from the Liverpool City and the Northwest region. So, and that's because there's a lot of good people based around here. There's a lot of good manufacturing businesses. I'll take you now into the production hall. You'll notice on the wall here, there's a nice graphic basically explaining the fact that we export 9 hours ahead, 9 hours behind, and this is to give us, maintain our focus, so to everyone in the business to understand that we have people out in Tokyo driving monos, we have people out in Los Angeles driving monos, and anywhere in between. In fact, we actually export to over 40 countries in the world, and it's incredible to be stood here to say that, to think that there's 40 countries in this world that have got this incredible car there. It's only at times like this, actually, when we have a chance to reflect on the things that we do and our successes, that makes me feel a little bit proud, as you can imagine. So let's go into the production hall and we'll show you a little bit more about where the cars were manufactured. So the good news is it's a lot cooler in here. So as you can see, we're in an 11,000 square foot space. This is where all the material flow is controlled. So basically above the showroom area, we have what we call our procurement logistics team, finance team, the usual back of office facilities that you'd expect to see in a business. That's really the heart of where all the parts are sourced from the suppliers. The parts come in a just-in-time delivery system. They're stored in this central area here, which is our stores. And then basically, every single car that we produce, there is an order, so the car is bespoke made. It's made to the individual order of the customer. And what happens is a sales order drives a production order. That production order then drives what we call a pick list. And that pick list is basically a list of the 2,500 individual components that go together for us to be able to assemble the car. If we walk down into the chassis dress, you'll see that we have a Virgin chassis here, which is pretty much as it gets delivered to us. The first point to mention is that we don't do any cutting, grinding, machining, molding, painting. Everything that we do here is to do with final assembly, and every component that comes in, there is a 2D drawing and a 3D model. So everything is bespoke for us, but we do all the final assembly here. This is a chassis that basically has been delivered fairly recently from our supplier. And if you walk further down into the car chassis dress, you'll see the cars are at very different stages of build. So each individual car has a number. That number is referenced to the trolleys that you'll see behind me. And on each of these trolleys basically has all the parts that are created by pick list. A lot of those are parts that have been already assembled, so individual components, for example, the pedal box. And these components are served from this area, which is just to my left, which is what we call the sub-assembly area. So you'll see on this area there's lots of components, individual components that have been steering arm, for example, individual components that have been delivered by our suppliers. These are all laid out fresh for Monday morning for the guys to start building these sub-assemblies up. So this will, when it's been bolted together, this will become an upright assembly for one of the corners of the suspension, and that will be allocated to a car, and that then goes over to the trolleys, and then ultimately it gets built onto the car.
There's a quick question from Nick. Where is the chassis made?
The chassis is made by a company called Caged, who are based towards Norfolk direction. Caged have been the original supplier ever since we started production back in 2011. And actually, vast majority of the suppliers that we still have are the people who originally started off our journey with. So it's been great to see our business expand, but it's also been great to see their businesses expand in order to serve the increase in demand that we have for the car. So let's show you some lovely components that have been assembled on the car. There are three main areas on the car. We call the central section, which is essentially where the driver is. We call this the driver safety cell, or the chassis, or the tub, some people might call it. And in essence, this is what gives the car the vast majority of its torsional rigidity and its vertical and lateral bending stiffness. It's a highly complex structure. You'll notice that it's in tubular steel. The reason for tubular steel was we felt the difference in weight save that was potentially possible with a carbon tub when we first started the company. There was only a 6 kilo weight save by going to a carbon tub. The investment in the tooling, but also critically the flexibility that one has with being able to change the chassis when it's tubular space frame is fairly infinite. We're actually on the 8th different iteration of the chassis in terms of minor modifications to it. With a carbon tub, it's very, very difficult to change the car. So basically, we future-proofed it, which is why we decided on tubular space frame. As I say, the car's built in 3 sections. We've got the driver safety cell, and on this particular car, the fuel tank system is already in. You see a lot of the wiring system, the BCU, which is the body control unit, and the electronic control, the engine control unit, the ECU, already fitted. We've got various components from the cooling system that's also fitted. And then, of course, the thing that's at the heart of the car, which is this lovely 2.5 4-cylinder normally aspirated engine, lovely put together by our friends at Mount Tune down in Essex. And the engine produces over 305 horsepower, 310 newton meters. We changed from the 2.3 engine that was supplied by Cosworth to Mount Tune back in 2014. The engine also features variable valve timing. It's also dry sumped, which allows us to get the engine as low as we possibly can in the car, which obviously helps to reduce drag as far as the form of the car is concerned. But vitally, it's the centre of gravity that we keep as low as we possibly can. The engine is what we call semi-structural, so it's solidly mounted to the chassis, unlike the vast majority of the cars that most people will drive on the street, that normally sit on rubber isolators in an additional metal subframe that is then bolted to a body and white structure. There's lots of overlap, there's lots of repeat of material there that all adds cost, complexity, but also vitally weight. And we're very focused on keeping weight to an absolute minimum with this car. It's all about performance, as we know. So by using the engine as part of the structure, it means that we can reduce the number of components around it, and therefore its weight. The gearbox is fully structural. So what we mean by fully structural is the suspension loads actually fed directly into the gearbox casing. So this gearbox started off live in Formula 3. It's been used for many years in Formula 3 and sports car racing. It's made by Hewland. It's 6-speed, it's sequential, and it also has a limited slip differential in it. And the limited slip diff has the preload that we designed when we first started with the car to optimize the car for traction and drivability.
So we have a quick question. How do you determine the optimum torsional rigidity and avoid over-engineering of the chassis?
Wow, that's a very good question. That's a good question, Nick. So it's all about performance ultimately. So you're absolutely right. How stiff does the chassis need to be? And you basically start with how much torque the engine is creating. So the more torque the engine creates, therefore the stiffer the chassis needs to be. So as we've developed the engine power from the 2.3 and 280 horsepower to the current engine and 305, what we've done is we've basically increased the stiffness of the chassis with various different modifications that we've made and subtleties. But that journey never stops actually, and we're actively involved at the moment in a load data capture exercise, which will be happening in earnest when we're allowed to test in the coming weeks, whereby the whole car will be instrumented and we'll be able to establish the exact loads that are going into the car. So we'll know areas that maybe we can perhaps reduce some weight, where perhaps we have slightly over-engineered the car, But that's absolutely the best approach as opposed to coming at it from the other direction, of course.
So there's a second question as well from Nick. It's what is the difference between semi-structural and fully structural?
Okay, so as I said, the gearbox is fully structural. So what that means is that all of the loads are directly fed into the gearbox, and the gearbox is the structure. So everything hangs off it, and it gives the car its rigidity in various different directions. Because the engine is based on a standard engine that is designed to sit in a normal road car, designed to take the loads, which is why it's semi-structural. So what we mean by that is we have structure around it. There are some loads that go through the engine, but not all the loads, and that's the reason for the differentiation between semi and fully structural. Okay. So once the car gets to this stage, it goes through a series of sign-off tests. The car is started. It runs through various different heat cycles. The car is checked for continuity, for electrical continuity, water systems, fuel systems. Everything is checked, and if it passes its gateway, the car is then lifted and it's moved over to this side of the building, which is called body and final assembly. This particular car that you can see here, this car has gone through exactly that process. So you'll see, just compared to the chassis on chassis dress, it's got some more components fitted. So vitally, the exhaust system is on there. This is a stainless steel system. It's ceramic coated from a heat protection perspective. And you'll notice now that it sits on its floor. And yes, this is a wooden floor. Nature's Best composite. It's the same material that is used in Formula One, the so-called plank. It's very durable. It's very hard wearing. It comes in 3 sections. So it is possible to replace any particular section should the car be involved in an incident. At this point here now is when we start to fit all of the various different composite components that starts to give the car the aesthetic that most people will be familiar with. There's 44 different carbon components on the car, which is a lot. And they all come together in a process which has been defined by production teams. The way the cars are put together actually was devised and developed by the guys who put it together, which is as it should be. This particular car is car 122. This car is going to Florida, I believe, in the US. And this car is part of a limited edition run of cars that we did to celebrate the last vehicles of this model that we're going to produce, which I think most people will be familiar with. So the car is called the Mono 1, and we've made 3 versions. We've made the carbon version, we've made Mono 1 red and Mono 1 white. Those 3 colours are pretty synonymous with our corporate identity. And actually, one of the cars is about to be revealed to a very lucky owner who hasn't even seen this car. I won't say his name, but I'm sure he's pretty excited. So this car has got lots of special treatment on it, and it really is incredible. It's in this stunning red. Looks amazing. And this is the first car that we've built in this series. So just to talk you through some of the features of the car, it's got some lovely unique branding on the Mono 1. So this, if anyone is keen enough to have looked at our logos, this is actually part of the vertical element from the Mono M, which when we designed it was all about one, because it's a one single seat, it's a singularity of purpose. It's also the best, so it's number 1. And hence the logo that you can see here. So this is all to celebrate the Mono 1 Special Edition, and then this graphic here is actually from the robot in the Bjork All Is Full of Love video, which is what actually inspired the car. That probably is a good time for me to tell you a little bit about what the inspiration was behind this car. Who's the type of person who buys it, what do they do with it, where do they drive it. So about 20 years ago, Ian and myself had an idea about owning a car with a singularity of purpose that really didn't exist at that time. There were lots of cars that were coming through that were focused on performance, and there are lots of brands that have sub-brands that are focused on performance. Porsche, for example. And pretty much every supercar brand now has a subdivision, whether it's the SVJ for Lamborghini, whether it's the RS brand for Porsche, and of course Ferrari has the same, and so on and so forth, and McLaren as well. And it's all about this differentiation of what we call a GT car, taking it more towards an ultra-high performance vehicle. And that's why the car only has one seat, because for us the design proposition was around a singularity of purpose. It's all about performance. And performance cars have developed over the years, particularly in racing, which, if you like, is the upper echelon of performance. Engines have been in the front, they've been in the back, there's been mid-engines, there's been flat engines, there's been all sorts of different levels of vehicle architecture, single seat, two seats, etc. And that's evolved over many years to Formula cars that we're all very familiar with. That's because it's all about performance. So for us, designing a car that had the singularity of purpose and was all about performance, it was quite clear from day one the car had to have a single seat. We never had a conversation about whether it should be two seats, whether it should be a tandem with one seat in front of the other, or maybe an offset of the driving position. It was quite simple. It had to be a single seat. People talk about two seats and they say, oh, well, driver's weight doesn't really upset the car that much, does it? And actually, on most of the cars that you guys drive that weigh around 1,800 kilos, having one person in the car or two doesn't really affect it that much, because the weight of the additional person compared to the overall weight of the car is a real small percentage. In this car, the weight of the driver, depending on the weight, of course, is easily 15, sometimes 20% of the overall weight of the car. So that's a huge amount, and that would have completely destroyed the weight distribution of the car and just completely killed the ethos of what the car is about. So having set the vehicle architecture to be what it would be, and actually the car is quite straightforward in terms of the way that it packages. So from a safety perspective, we didn't want the driver's feet to protrude anywhere past the front axle line, which is here. So that basically is where the chassis starts. We then put the 96% mannequins in, which basically defines the seating position and where the engine can then be mounted. And because obviously it's a 4-cylinder engine, that then defines where the bell housing is, and of course the gearbox. And before you know it, you've got your wheelbase. And then of course it's all about the aesthetic. And I have to say, I can take absolutely zero credit for the way the car looks. It is the first thing that attracts people to it, because it is incredibly designed and constructed. And as I said earlier, the influence for the car was a video by an artist called Bjork, and the video was called All Is Full of Love. Check it out on YouTube. It's a very long time ago, and it was the influence. And the reason being is there was no other single seat car that was out there, or anything really that would influence. When you design a new product and you're starting completely from scratch, you have to take influences from nature or from different forms that are out there, which is exactly what we did. And the robot in the video has this mixture of these lovely organic shapes. And if you check out the video, you'll understand the areas of the female form that I'm actually describing. So there is a link on the. Oh, great! Go check it out if you get a chance after the call. So you'll see there's these lovely organic forms, but then there's also these exposed mechanical components, and there's a real beauty in these components. You'll see CNC machine components, all bespoke for the car. And as we move backwards towards the rear of the car, it's quite like a superbike in the sense that. Superbike at the front is mostly fairing and forks, and then as you start to move towards the rear, you see the rear swing arm, you see the engine, you see a lot of and there's some absolutely incredible detailing on the engineering side of the car. And obviously how engineering works with the design department is very, very, very important. And I guess that's down to relationships. It's also based on trust as well. And I guess that's why, one of the many reasons why Ian and I get on so well. We both understand each other personalities, but we also understand each other's strengths and also weaknesses as well. And how we all interact as a team. And I think the reason why the car looks so incredible is because it's singularity of purpose, but basically we've got strengths and we all grow off each other.
Before we move on, so there's a question from Chris. Even with the singularity ethos, can you foresee a two-seater model coming?
So you heard it here first. Yeah, I mean, never say never. I'd say that Mono is the car that defines our brand. We're very similar in that sense, I guess, to Porsche with the 911. So there will always be a Mono, and I'm about to take you to show you some of the new, latest versions that will be coming out in the years to come. So we're going to do that in the Innovation Centre next door. So we will always have Mono, and it will always have one seat. But of course, we are currently looking at our product development strategy and our plans for the next 5-6 years. I think it's fair to say that a car with more than one seat will exist. I'm not going to be drawn into how many seats it might or might not have, but it will definitely have more than one.
And the next add-on to that question is because at the end of the video, the build video, there are 2 robots. So it was just a comment to add to the previous question. And there's another question from Chris Lee. There was a hypercar rumored in 2017. Is that still on the cards?
Yeah, that is the vehicle that I'm talking about. It's a vehicle, as I said, with more than one seat. The design team is responsible for this car and the 2 vehicles that you'll see next door. Very soon, they're moving into the concept phase on that very vehicle. So that's going to be a journey that is going to be. It's incredibly drawn out process. Predominantly because, again, as I said before, when you're designing something from fresh, you have to look very, very diverse. And for us, as you can see, we're not a business that's about being the same as everybody else. We dare to be different. And in fact, that's actually one of our core values that we encourage with everybody in the business is to dare to be different and have the confidence to do things slightly different and think differently. And when you do, this is the kind of thing that can happen. So I think we've pretty much covered everything we wanted to cover in here. I think probably it's worth a shout out to the suppliers actually, who've supported us over the last 10 years. We've got lots of local suppliers, as I said, very good relationships. Without them, we wouldn't be here. Since we've been here, we've created over 20 jobs within BAC. We've also actually created 40 jobs in the supply chain, which we're very proud of. So as we grow, they grow, and we all share our success together. So thanks to everyone for supporting us. I won't mention every single supplier, because if I mention one, then other people will get upset if I don't mention the other. But just thanks to everyone for supporting us and keeping this journey going. So I'm going to take you now from the manufacturing centre, which is this building that we were in. This is 11,000 square foot. Normally, it's full of lots of people scurrying around building cars. So we've got about 2/3 of the workforce coming back into here on Monday, and we've had a gradual process of people in this building. We come out the side entrance. Hopefully the wind noise isn't too bad on the microphone. This is our latest building. This is the Innovation Centre. This is again 11,000 square foot, and this is where a lot of the future magic happens. We keep a low key in terms of what we do here, so there's no branding on the building. It's a little bit like the TARDIS actually. When you get inside it and you put the blinds down and you work, it's incredible. The day goes so fast. We move at such a fast pace, but it's where all the future magic happens. So let's take a look inside, and I'll show you some of the various different areas of the building. It's a lot cooler in here as well. So this is the reception area of the Innovation Centre. This building was opened by Mayor Anderson 27th September last year. We've actually been in here just over a year now. And it's been transformational for the business. We were 22 people in the office upstairs next door, and we needed to expand. This building was available, and with support from Mayor Anderson and the team of the City Council, we moved in here in June last year. Complete renovation of the inside of it to make it to our bespoke use, and it's been really good. It gives people their own space, it allows people still to interact, but it gives people their own space to do their own magic in their own individual department. This area we stood in here actually is where our head of service and after sales sits. He manages his team of people behind me, which is in the area we're taking shortly. And it's where conversations happen in any one given day. He's talking to people in the US, he's talking to people in Hong Kong or Japan, he's talking to people all across Europe. So his day's very varied, as you can imagine, particularly over the last 3 or 4 months. We're taking now into the service area. I think all of the cars that are in here, correct me if I'm wrong, the customers are happy for us to show their cars. So I just wanted to cover that point, because we do have people who have lots of cars, and sometimes their wives aren't aware that they have so many cars that they do. But we can be discreet if we need to be. So into here. So these are just some of the cars that are in the service. We start with the first ever car, which anyone who's familiar with the business, we refer to it as ESO 1. What that actually stands for is Engineering Sign-Off Vehicle Number 1. So this was the first ever vehicle that we made. This is the car that Jeremy Clarkson drove in episode 2 of Series 20. If you haven't seen that, go check that out on YouTube, because it's a great episode. 7 years ago that was, which is quite staggering to think about it, really. The car's in really good shape still, we still use it. This was, the branding that's on the car here is to celebrate, but also was part of a big event we did with Pirelli. Pirelli is one of our strategic development partners, who has developed bespoke tyres for the car. The reason being for that is, with a car that only weighs 580 kilos in this case, you can't just use a standard off-the-shelf tyre. It just simply will not work and would actually be dangerous. So we've been on a 2-year development program with Pirelli, and they've developed a bespoke version of their award-winning Trofeo R tyre, which is fitted as standard to the new 10R. This is car number 1. We've actually got car number 3 in. So this is this vehicle was owned by the previous owner. The car's come in now for some work, some upgrades, and some service work, regular service. It's all ready for when the season starts. Car next to it, I think, is car 74, and I think one or two of the people on the call today might be very familiar with that car. And then this car here, stunning colour. This is owned by a gentleman in Jersey, and this car is actually for sale, as was this car, but this car's subsequently been sold. This car actually is for sale. We're selling this on behalf of the customer. I think it looks incredible in this. It's very technical. It gives the car a very unique appearance, and something that's probably not very well known in terms of car design. In styling studios, they use a material called Dynoc, and they actually use a colour that's very, very similar to this. The reason why is because it shows off some of the very subtle styling features that in other colours, some of those perhaps lost, and that's why I like it so much. It's also very technical, and I think it's very much in keeping with the brand of the car. This particular car has got some incredible optional extras fitted to it, and perhaps we should focus on these here, a little bit about our carbon hybrid rim. And before Nick asks, why is it a carbon hybrid rim?
About the tires, where Nick is saying why can you not use a standard tire? Sorry. Yeah. Which I think you covered, but just a bit more.
Yeah, predominantly that's around the loads that the car generates through its weight that basically works the tire in order to get for the tire to work optimally. There is a certain amount of static load that's required for the tyre to work, and dynamic load as well. And when I mean work, grip so that you can steer necessarily about performance as such. Of course, if you then take that to the next level, as you then develop the tyre, of course, it's all about braking performance, wet performance, dry performance, lateral grip, how the tyre gives up its grip, how it regains its grip. So there's an awful lot of work that's gone into this, the tyre. But just looking at this wheel specifically, the rim is made from carbon, and the centerpiece section is made from forged billet machined aluminium. The reason being is we all think back to those days where we probably weren't listening in our physics classes at school. I equals mr squared, so that's all about moment of inertia, and it's all about where weight saved is the most critical, and that's because the radius, which is that distance there, is to the power 2. The most important place to save the weight is on the rim edge, so that's why this is made from carbon. The negative thing with carbon is it's not particularly strong in bending, and so therefore to get the lateral forces that we need and the rigidity and the strength in the spoke, would have to go to actually quite a considerable size section of carbon to give us the lateral stiffness that we need. And that, of course, adds weight, and so therefore the optimum way to do it is by using the right material in the right area, which is what we do. And this is a patented system that's been developed with Dymag, who supply the wheels for us, and we've actually taken that to the next level on another car, which I'm going to show you shortly. This car also features carbon ceramic brakes. That entire package there saves 4.5 kilos per corner from the standard wheel and disc. That car, Pushka, help me out, is for sale. I think that's at 140. That's including all taxes, and it's done approximately 3,000 miles. So that's a fantastic buy for somebody out there if anyone's looking to buy a mono. Current car, brand new, is 145,950 plus the VAT plus the options. Just if you just wanted to do the mental arithmetic there. And there's not many of them left now. So because the Mono R, which is the car I'm going to show you shortly, is sold out, we're expecting the second-hand residual values actually to start rising, because there really isn't a new car that you can buy other than the current W for the next 2 years because of Mono R. I think we're going to go next door,
Mono R first,
and then we'll come back to this one. So this area here, this is our innovation studio. And essentially what we do here is we use this area as what we call a pilot hall. So the first builds, the first customer car builds, the first 3 actually, in this case, are made in this area. Why is that? Well, I'll tell you why. Because the people who designed it live just to the side of this door, and you can have a sneaky peek in here. I shouldn't, but I will, especially for you guys if you just have a little peek in here. So obviously normally this is end-to-end with engineers, all socially distanced at the moment, of course. So we have our engineers, we have the people from the engineering team, we have an engineer who runs the test car, who's responsible for all the data logging and looking after that car. Down is the design guys, who are responsible for the exterior and the interior. I have come up with crazy colour schemes like this that might be familiar to one particular person on the call today. We won't show you that much for too long, because that's going to be a huge reveal when you eventually get to see the car, which is in build over here. So it's the same process. It's the same process that we've made the current 126 cars And to the untrained eye, it probably doesn't look that different, but it is dramatically different. So again, we start off with the driver safety cell, and again we have the engine, and then we have the gearbox. Let's say the vehicle architecture or the vehicle platform, as we call it, is unchanged, but there's so many subtle changes that have been made, and we'll probably start at the front. Maybe if you can film through here, Kanika, then the folks that are on the call can see. If we come through this way, maybe the guys can see that the front end is well, basically looks like a piece of Swiss cheese. It's been FEA optimized to death to try and get as much weight out as possible. In some cases, we've changed the components. In this component's case, from aluminium to magnesium, and this is how we've managed to change the vehicle's weight from 580 down to 555 kilos. So it's a huge weight save. I mean, it's 25 kilos that we've saved on a car that was only 580 kilos. So to save 25 kilos on a car that probably you guys drive that weighs 1800 kilos, it's a fair weight save. And that's the kind of thing that typically you'll see on an SVJ Lamborghini or a Porsche RS. But to save 25 kilos on a car that only weighs 580 kilos is quite staggering, really. And we achieve that in a few ways. Rationalization of components, first of all. So if something absolutely isn't necessary, we can integrate some parts, and that's what we'll do. We've changed materials, so in this case we've gone to magnesium on the shear plate. We look at the belt housing. The belt housing is actually the connection point between the engine and the gearbox, which is what this component is. It's the only cast component on the car. This is also made from magnesium. Just that individual change saves 6.5 kilos from the aluminium version to the magnesium version. And then again on the gearbox, we've changed from aluminium to magnesium again in the case of the rear end of the gearbox. So another kilo that's been saved there. So these are quite significant changes. This is the first customer car, so we're very proud of this. We're very proud of all of our cars, obviously, but this is a huge achievement for the team. As you can see, whilst we're finishing off with the sign-off of the test car, which is behind us, which I'll show you shortly. Production has already started, and these are the first two cars. So this car, I think we can say, is going to Holland. We won't mention the customer's name. And this car is going to Belgium. Yes, which is this car here, and then this car, which will start to have more components fitted to it as they come in from our supply chain. This car is going to Hong Kong, I think. Yeah.
Just a quick question on the magnesium. Why didn't you cast in magnesium just to begin with?
Okay, so there's two reasons. Cost being one. The gearbox is already the fourth most expensive component on the car, of supporting work and the engine are the two most expensive. It's an incremental weight save, so it's not transformational, changing from aluminium to magnesium on this particular component. So in terms of the cost versus the weight save for this component, it just simply didn't make commercial sense to do it. Also, magnesium is great in the sense that you can save weight, but it's very, very problematic in terms of corrosion. And so for us, there's some very special treatments that are applied to the components that are on it now. And I think that that's in keeping with the special nature of Mono R, which for those on the call who don't know what Mono R is, Mono R in essence for us is going to be the last normally aspirated car that we'll ever produce. You may have seen recently, if you follow us on Instagram or any of our social platforms at Discover Mono, you probably see this thing revving to 9,000 RPM. Externally, it doesn't look significantly different from the previous engine, but I can assure you, other than the block, this engine is completely different to the engine next door. And in fact, the block has been bored to change the bore and stroke ratio to allow us to be able to rev the engine higher to achieve the 9,000 RPM red line and thus achieve more power. You'll see on here as well, there's this incredible titanium exhaust system I can't stop stroking it whenever I'm around the car because it's just gorgeous to look at. Lovingly made by our supplier Alunox in North Wales, who have been with us again since the beginning of our journey. And of course, a serious weight save to be had from the exhaust as well. So basically, it's all to do with clever usage of materials that we've managed to, in the most, that we've managed to change and save a lot of our weight, but also through further FEA analysis as well. For those of you who didn't see the car at Goodwood last year, this is Mono R. You perhaps just try and get the full car in character. On first glance, you're probably thinking, well, how is it different? It's radically different. There is no wooden floor anymore. It's a new aesthetic, a new design DNA. So we call it the new reference in 4 different ways. With the design DNA from the aesthetic, you'll see that everything's got more of a thinner form, but gone even more organic. There's a decluttering that's happened in lots of different areas, specifically around the front, to reduce frontal area. So those familiar with the old car will remember there were 4 lights that used to be positioned on either side. We've now integrated 2 of those lights into one here and here, and given the car its real distinctive shape and also appearance. So these lights here were there's no legal requirement on where you put the main beam. And this was inspired by the GTE cars that you see racing at Le Mans with the 2 yellow lights typically in the middle of the car. It allowed us to create this aerofoiling section really around the driver in a plan view, which means we can get more air through the car, vitally to cool the radiators, which have got bigger in size. So you'll notice that the ratio of what we call the body to the upper, the lower body to the upper has changed because the radiators have got bigger. While the radiators got bigger, well, the engine's making more power and therefore it's rejecting more heat. So we needed bigger radiators and therefore we need more air to cool those radiators. So everything is all as a result of the increased power requirement, but also obviously done in this exceptional way. The car maintains its beauty and its appearance. Some real lovely details in it actually. If you look at this area behind the front wheels, you'll notice that we've created this negative space here. Typically what happens with any rotating wheel is you get a pressure buildup of air towards the back rear end of the wheel. So by opening up this section, it means that we can release the air, we can channel it down the sides of the car and use it in our favour. I think the other major thing to mention as well about the bodywork is that another world first for us and the industry is that it's the first car in the world to feature graphene enhanced composite body panels. Graphene was first discovered at the University of Manchester 15 years ago, of which I'm an alumni, as luck would have it. So I've been familiar with the material ever since it was discovered. Essentially, what it does is it enhances the structural property of the carbon fibre. That basically is what it does, and what that means is to achieve a given component strength, it means that we can use less carbon fibre layers in a component, therefore making it lighter. So this body structure is actually 12 kilos lighter than the original body structure, which is a huge weight save. We're very proud to be doing things like this because we're the first people in the world to be doing it. We're creating a lot of interest within the industry as well. And because as a business we don't compete with any other car company, we're quite happy to share some of those at a price of course. We're quite happy to share some of those lessons learned with people in the industry. And also outside the industry as well. It's incredible. The SpaceX program launched last night, 6 months ago. I spoke to the CTO of the SpaceX program about graphene when we launched the car at Goodwood. So we're raising lots of eyebrows, not just in the automotive sector, but also across lots of different sectors as well with our use of materials. And that's something which you'll expect to see a lot more of as we go on and as we develop. So that's Mono R. The good news for us as a business, sad news for some of the people watching, is that it's already sold out. So it was incredible for us to launch it. And I've already pre-sold the car. So it's so heartwarming that people are as drawn to the car as we were when we were designing it. It will be the last car that we ever make with a normally aspirated engine. And that's why we have this air intake on the side, because in essence what it does is it compresses the air, forces the air into the engine through the intake here. And that's one of the ways that we can produce more power from the engine. More air, more fuel means that we can produce the staggering 343 horsepower from a 2.5 litre engine. It's actually a world record for the highest specific output of a normally aspirated engine in series production. So lots of firsts with this car. I just can't wait for the customers to drive it and see the smiles on their face, because it is incredible. And the good news is that all of these weight saves, all of these increases in power and so on and so forth, they all translate to an even better or an even more incredible, probably a better way to describe driving experience. So super exciting. A couple of little minor things on here. I think anyone who's seen a mono or driven a mono will know that we're not brilliant at everything, and wing mirror design was probably not our strength. But we do listen to our customers, and as you can see, I'm putting a lot of force on that now. It's absolutely not moving, so these are going to be transformational for the new customers. These parts themselves are 3D printed. So we use around 42 different components on this car are 3D printed. For those of you who don't know a great deal about 3D printing, 3D printing has been something that's been used in the past for more prototyping, to allow you to put a part on a car, to look at how it fits with its neighbouring components, to give you a part before the series production parts arrive. They've not usually been parts that would allow you to actually use them in production. But in partnership with DSM from Holland and with Multimaker and a few other 3D printing manufacturers, there's a new material that's come through which is called Novamid 1030, and it's what's called carbon filled. So it means that the material itself has got strands of carbon in it which give it its structural rigidity. And what that means is that we can actually use those components in series production. So it's, again, it's groundbreaking that we're using 3D printed parts in series production. But for this volume, it gives us freedom of flexibility of change. We're actually making the components ourselves. So for the first time in our history, we're actually manufacturing the components as opposed to issuing it to a supplier to our design and getting that brought in. I think I'm going to take you upstairs now and actually show you some parts that are being made, which is pretty cool. And then I think we're going to have a question and answer session about any questions you guys have got. Before I do that, I'm just going to show you the next iteration of this car, and I want you to focus on this particular area and the aesthetic of the car. So in essence, we're maintaining the design DNA that was first, or the new design DNA that was first seen on Mono R, but because of the global increase in demand that never stops, relentless, for the car, we need to meet emission levels in particular countries, and predominantly mainland Europe. There's 22 countries which we need to tap into, and there is demand there for mono, but it has to meet EU 6D emission regulations. And the only way to do that is with a forced induction engine. So earlier in this year, we should have launched at Geneva. Sadly, we didn't because of the outbreak of COVID. We ran an event here called Geneva Cool. A few of you might be aware of that. And we launched this, which we internally call Mono S. It stands for forced induction. And in essence, you'll see that the car is, from an appearance perspective, is very, very similar to Mono R. The intake area I have to focus on is exactly this aperture here, and this is where the ram airbox for the normally aspirated engine sits on Mono R. Except on here now, this is the intake system for the turbo and the inlet system. Obviously then through an intercooler, feeds the turbocharger, and the engine produces 332 brake horsepower and staggeringly over 400 Newton meters of torque. So there's been quite some considerable increases in terms of some of the components, for example, drive shafts, suspension, and so on and so forth, that have been increased to handle the additional torque. All the bodywork, again, is a continuation of Monoar, so therefore it also has graphene-enhanced composite body panels. And this car, which we've already sold, I think, 15 cars, which is quite staggering. And we're actively in talks with people in around 4 or 5 new countries and territories around the world. Lovely little detail on this car. Again, it's been carried over from Monoar, so the lightweight brake calipers, some of the magnesium components I've carried over. I think we're going to go upstairs. But with a tool which we use, which is called generative design, which is done in partnership with our software partner Autodesk, it allows us to further a lot of our components and reduce weight yet further. So as an example, what normally happens typically with a part is an engineer or a designer will design a component, they'll apply a load case, they'll look at the FEA analysis, and they'll decide where they can save some mass, or they perhaps need to add some material due to stress concentrations or whatever. This process happens hundreds and hundreds and hundreds of times in a cycle, where the algorithm is looking where it can take material out. It then does the analysis. If it needs to add weight in it, it adds it in. If it can take it out, then it will reduce it. So you'll start to see that the wheel has got all sorts of pockets and gaps and structure to it that's very much in keeping with nature, because nature has evolved over the years, again, through the loads that we as humans we encounter. And so we've managed to save another 1¼ kilos just out of that centre section there. So that wheel there, as it sits here, and it's a 17-inch wheel, by the way, that wheel is ½ kilo lighter than the wheels in Formula One that are 13-inch. So it's a staggering achievement. And it's just all part of our continuous push with innovation. We know that there's a direct correlation between weight save and performance. And so for us, they're measurable quantities that we know if we save a certain amount of weight, we can save a certain amount of lap time and go even quicker, which is obviously what the main focus of the car is. And also make the car nice and easy and friendly to drive, which is kind of part of my remit, is to make sure the car has a lot of accessible performance to anyone or any experience and any driving experience, both on the road and also.
So a quick question by Nick is, what is FEA? Is it finite element analysis?
Yes, it is. Yeah, exactly right, Nick. Yeah. Sounds an interesting chap, Nick. This. Come up and come and see us for a tour, Nick, if ever you get the chance. There's a lot of cool things up here that I think you'll probably be interested in. I'm just going to take you upstairs now onto a mezzanine area that we've got, which we kind of is a soft air meeting area that we have, not quite as formal as the office, where we discuss our innovations that we have. This is the area that we've got here. I think these 3 individual components that I've got here. I'll lay them down on here on top. Probably better to hold them up. This is a 3D printed part. This is the center section from the wheel. I'm going to show you the actual ones themselves in a minute. This is the new center section, which is quite similar. We restrained the 5 spokes to make sure that we continued the 5-spoke aesthetic, but we reduced the mass. That's how far you can take it. I don't know if the camera's picking that up. Basically, you can take it so far that it becomes literally like a piece of Swiss cheese. But obviously, your manufacturing constraints need to be considered of how you're going to be able to machine these components or 3D print them. And of course, for 3D printed metals, that's a new technology which we're looking to tap into as well. It allows you to do those kind of things. So this is the real components, if you like, or the fully machined components. That's the center section, and it's incredible just to pick these 2 up and see the difference in the weights. And of course, this is finished wheel, which Dymac produce. And that's a 17-inch wheel I've got in my hand there, and that's 4.7 kilos. It's phenomenal. Even the valve is lighter actually by 12 grams before anyone asks. So, and then just behind me, or behind the camera rather, is our 3D printing area. It's an expanding area we've got now within the business. These are some components which are going to be the inlets for the inlet system. So this is a print job that's been running over the weekend. The great thing with these things are it doesn't need any human intervention. There's cameras inside there, so you can see from a remote mobile device what's happening with the job to see if everything is working and everything is going to plan. We have the various print job sheets. We have, that is an oven, so we dry the material. So all the material is stored. Very SpaceX looking type bags. This is how the material comes to us. Then gets dried in the machine, and then basically gets fed by the 3D system onto the rear, and the parts get printed. So those parts will be ready to be taken out tomorrow, and then dressed and then fitted onto the car. So I think we're pretty much ready for the Q&A. And before we do that, I just want to tell you a little bit about some of the merchandise that we've got. This is available at bac-mono.com/shop. And it's an expanding range of clothing that we've got. And it's not just Me Too type clothing. The main reason why we've done this is we've done lots of different events over the years with our customers, and it's interesting to see what people wear. We consider driving to be a sport, and obviously the right sport requires the right clothing. When you're driving the car, there's lots of different things that you're exposed to in terms of the environment, the rain. You're obviously working quite hard when you're on the track so that it needs to be able to breathe, where you put things, how the pockets work and so on. So this is our driver's jacket, which we've made in partnership with Gore-Tex, who supply the fabric, and the people who manufacture it in Hong Kong, KTC, make a lot of high-end merchandise for various other brands. This is all bespoke designed by our own guys here. How many times have you sat in a car and your keys have fallen out of your pocket and they've slid down the side of the seat, or your money's fallen out with your credit card? Total nightmare. No one's ever really thought of why pockets work the way that they do. So we kind of turn that on its head. The pockets work in the opposite directions when you're in the car, because of course you're limited with the space that you've got. You can access your pockets. The clever thing behind that, of course, is that the seat belts come over in this direction here. So when you're in the car with the seat belts, it means that you can, guess what, still get in your pockets, and you can still access everything. You're not restricted. So it's very functional, but like all things that we do, it also looks pretty cool as well. And then to complement that, we've got a series of other items of clothing which have got various different designs on, different colours. This sizing chart's on the website as well. Guys, if you want to go on there and see what size you are, wear a BAC t-shirt with pride. It's nice to see them out there. That basically is it for today in terms of the tour itself. I'm going to take you down now, and I'm going to sit, and I think we're going to have some questions. For as long as people have got questions. We'll work our way down off the mezzanine. The lighting in here is really, really good, which is obviously very, very important when you're looking at new designs, and you're looking at reflections, and you're looking at quality of components, which is why it's lit the way that it is. Lots of natural light, but also lots of additional lighting as well. So I hope everyone's got some good questions. I bet Nick's got some good questions.
So I'm just going to hand you over the chat box.
Oh, you want to read it? Just share.
Okay. So the first one is there a spiritual predecessor to the Mono, i.e. historical car or mark, which influenced thinking into a degree?
That's a great question.
Questions from Craig.
Okay, thanks for the question, Craig. It's a good question. I think there was a movement probably from the F40, Ferrari F40, which was a car that was basically just designed for all-around performance. That was probably the beginnings of it for us. There's always been, of course, the RS brand with Porsche. But at that time, obviously there's the 340R from Lotus, there's the Renault Sport Spider, an all-aluminium car with composite body panels, no heaters, no doors, no windows. And I think these cars were cars that started to open people's idea to what we would call an extreme car, a car that's all about performance, all about driving, and offers fantastic value for money. You may say £145,000 was still. The short answer to that would be is go check out Evo's leaderboard, where they test the same driver in lots of different cars around the same circuit. For this car to be 5-6 seconds quicker than cars like the Porsche 918, and even be faster than a P1 GTR fitted with slicks, is quite incredible. So yes, it costs £145,000, but it is incredible value when you compare it to the other performance cars around that are much slower and cost in some cases 10 times more.
The next question is from Nick. How many cars do you have to produce or sell in 2020? This is another Nick here, by the way.
Okay. So as we currently stand at the moment, the car that's on the right-hand side of the service centre, that's the current car that we're producing. We have around 5 of those cars left, so there is still time to place an order for one of those cars, and that car will be produced in this calendar year. In parallel, we're already beginning to build a Mono R car, which you've seen. We produced 30 of those. They're all sold. And obviously there's an overlap between the current car and this car. Very shortly, once those 3 cars have been produced, then series production will be transferred over into the new building, and we'll turn our attention and focus to the forced induction car. That car is also on sale as well, so if people want to order that car, they can. It's emission compliant all across Europe with its EU60 emission compliant and other things as well that are needed in Europe, like drive-by noise and so on and so forth. It's already been for a pre-TUV approval test in Germany. So we're working closely with the authorities there to make sure that we've got all the I's and cross all the T's. So it's also possible to place an order for that car, but deliveries of that car won't be until the end of 2021 and actually probably beginning of 2022 now with the number of cars that we've already pre-sold.
So the next question is from Gavin, who has recently just purchased car number 99. And he enjoyed the tour a lot. His question is, can I fit mirrors?
I think we need to, it's the obvious question, is that we perhaps need to look at a retro for old versus new. And that's a really good question, actually. So, and noted. So we'll start looking into that. Nothing happens overnight, so just bear with us. But I think that's a great idea of some way of being able to upgrade the current mirrors to the new ones.
The next question is from Nick. Do you offer track experience days, and what are some of the comparisons drivers give when comparing BAC to cars like 20S, for example?
Very good question. So yes, we do. In fact, they're organised by this young man who's asking the questions, and his fiance who's actually holding the camera as well. I should have introduced you to these guys earlier, so apologies for that. Yeah, so we do what we call our Mono Experience Days. Typically, it's around. They'll usually be in the UK, but sometimes they're abroad as well. Typically, places like Spa or Northern Europe. There's a cost associated, and usually that cost is there's an offset with that cost if the customer decides to buy. In terms of performance to a 720S, wow, that is a good question. I mean, I can only compare in terms of numbers to on the Anglesey circuit, where the car is quicker than a P1 and quicker than a P1 GTR. I'm not familiar with what the lap time is for the 720S if it's been around Anglesey. but I know it wouldn't be as quick as P1 GTR on slicks. I think there's something like it's like 4 or 5 seconds time difference, which is a lot on any duration of lap. Chiefly, that lap is enough for others a 1 minute 7 seconds. It's not a 2 minute lap, for example. So to be 4 or 5 seconds quicker on that type of duration of lap is quite something. Obviously, around places like Silverstone, places with bigger, longer straights, then the time difference is going to be different. It's circuit dependent. But we have got quite a few customers who've got 720Ss and have also got monos as well. They complement each other really well.
Yep. Okay. Thank you. The next question is similar to next question. Do you do driver training specifically tailored for the mono? Okay, this is from Peter Joda, says he owns the red 101. He's asking, do you do driver training specifically tailored for the mono?
Yes, we do. So we do our mono experience days and our coaching sessions. We run with what we call a lead and a follow.
Yeah.
So typically, the Ollie Webb drive or the drivers that we use when available, and they will lead. And the idea is that you follow exactly the route that he takes because they're the optimum lines. Based on your experience, it will depend on the pace, and throughout the day, you'll start to build up your pace. You have debrief sessions after every time you go out in the car, typically 6-7 laps. A rest, think about what you've achieved, some challenges that you've got, some places that you want to improve on, and we develop it that way. And it's great to see people develop. It's like any sport, when you start to get better and better and better at it, it gets more and more and more rewarding. And I think that's, for me, one of the great things is seeing customers interacting on a mono experience day, where they're getting out the car and they're talking with other owners about what gear they were in going through Beckett to 100 miles an hour or whatever speed they were going through it. What speed were you doing? It starts to become a little competitive, but also really, really fun to watch.
So the next question is from Paul Jenner. And the question is, if two of you buy one for the track to share, can you adjust seat or bedding?
Very good question, Paul. And that's one thing that I've not mentioned throughout the tour, is that the seat, the optional seat, is made to measure. So what that means is you sit in a fixture which is actually based next door, and we can bring the fixture to you if travel is an issue. We're doing that next week, actually, for one particular person who's on the call. And they sit in a form, then molds to their body. It's patented technology, and it goes to our trim shop and is trimmed. It's very, very straightforward to lift the seat out, which Pushka is just demonstrating now, so we'll just show you. So that basically is the seats in parts. That's obviously backrest. And the substrate is made from a patented material. It's super light. What it means is that your body supported in all different areas. In the event of when the car starts to slide, it means that your body is feeling that throughout its entire length, not just hot spots that you would normally have on a normal seat. And of course, from a safety perspective, it's optimum too. So this seat is that simple to take out the car. So of course, you can have 2 seats for yourself and your buddy. We just need to argue about who's going out first in the car. It's actually a very good point, because fractional ownership is perhaps something that might appeal to a couple of people that are on the call today. As they start to get more and more familiar with the car, then who knows.
So the next question is from Chris Fox. What downforce is generated at what speed?
So obviously it's a commercially sensitive number, that is. I can't quote exact numbers, but what I will say is the way the car is designed is that every single thing in the world generates lift. So what we do is the downforce that is created on the car is to counteract that, to keep the car nice and stable at high speed. The aerodynamic brief really wasn't around creating how much downforce we could create. It was around reducing drag, whilst also having efficient downforce. such that we could have a supercar credible top speed of over 170 miles an hour. The way the car creates the vast majority of its grip is mechanical grip. And the reason for that is that mechanical grip is so much easier to manage. And mechanical grip is also linear with speed, whereas aerodynamic grip isn't. And there's a huge transition zone normally with high downforce cars between lots of downforce and into the downforce and mechanical zone. Mechanical. It's very, very tricky to manage. Even some of the best Formula One will struggle to do it. But it means that that's how we keep the car very accessible to drive. If the car had lots and lots of downforce, it would be exhilarating to push the car through a corner, but it would mean that it would be almost impossible for you to play with the car and slide the car and drive it in a style that you like. And ultimately, that's what the car is all about. It's about enjoyment. Entertainment. It's about giving guys the best driving experience of life, which is what you get with this car. You sit in the middle. There's nothing obscuring your view. There's no A pillars, there's no B pillars, there's no rear view mirrors. There's nothing there at all. Very similar to a motorbike in that sense. Good interaction. You sit in the middle of the car, so it turns left the same as right. And it's just a totally unique experience. If you've ever watched Formula One and dreamt of a parallel life where you thought you could have been a racing driver, that obviously allows you to live that dream.
That was the last question. So if there are any more questions, I don't think there are any more questions. So
That's it.
Okay. Well, listen, it's been, I can't believe we've been talking for an hour and 20 minutes. It's gone really fast. Really appreciate the support, everyone, today. Stay safe. Stay tuned as well. Please follow us on Instagram, Facebook, and Twitter @DiscoveryMono. It's the best way to keep everything that we're up to. And of course, the website, bac-mono.com. It's a new website that we launched earlier in the year. And of course, go check that merchandise out and let's spread the BAC word.